Hello, everybody. Welcome to Silence Abounds Science at Home, where we will discover home lab magic. We will be doing experiments demonstrating scientific principles, concepts, and reactions in chemistry, biology, microbiology, microscopy, and even forensic science. Welcome to my channel. Hello, everybody. Welcome back to Silence Abounds Science at Home, where you will discover home lab magic. In today's episode, we're going to be discovering or learning about the luminol reaction, the luminol oxidation reaction. You may have heard of luminol before if you watch programs, detective programs, forensic programs, and CSI and so on. They use luminol a lot. Luminol oxidation reaction, it is what is known as a chemiluminescence reaction that produces visible light. It is often, as I said, used in forensic science. The luminol oxidation reaction that we're going to do today uses potassium hexocyanoferrate, which is a specific variation of the standard luminol chemiluminescence reaction involving hydrogen peroxide. Potassium hexocyanoferrate provides an oxidizing environment that facilitates the oxidation of luminol, which results in the emission of light. Luminol glows in a basic medium, and in this experiment, we're going to use sodium carbonate to provide that medium. Luminol and hydrogen peroxide are then added to the sodium carbonate, and then we add potassium hexocyanoferrate to initiate the reaction. The reaction is best demonstrated in the dark, so a portion of this video will be carried out in a dark room. This experiment comes from the kit from MEL Science. MEL Science is a subscription-only service that provides chemistry kits every month. And in these kits, you contains all the reagents and consumables that you need in order to perform the experiment. These kits are a good way to do home experiments without having the expense of having to buy lab glassware and your own chemicals, because in these kits you have everything you need and you don't have to purchase anything extra. Also, within these kits are usually 2 different experiments, and there's usually enough reagents to do each experiment at least twice. So please check out MEL Science for more information. So what I need in for this experiment is a conical flask. I need hydrogen peroxide, luminol, potassium hexocyanoferrate, and hydrogen peroxide, and also 10 ml of water. So with that, let's start the experiment. So the first thing I need to add to my conical flask is the sodium carbonate. So I'm going to take a bottle of this reagent, and it requires a whole bottle to be added to the flask. So I'm going to empty that into the flask, like so. And then it requires 10 ml of water, and I've got a syringe to measure out the 10 ml. Okay, I've got 10 ml. So I'm going to add that to the flask. Next, I'm going to add 15 drops of the luminol. I've got the luminol here, and then I'm going to add 15 drops. Okay, 15 drops of luminol has been added, and then I have a bottle, a small bottle of hydrogen peroxide, and that requires me to add all of that into the flask. So I'm going to add all the hydrogen peroxide into the flask. Okay, that's all been added. Put that aside. The next part of the reaction needs to be carried out in a dark room. So please bear with me while we move into the dark room. The video is going to be dark for a while. And then once I'm in the dark room, I'm going to add drop-wise the potassium hexacyanoferrate. And then you will eventually start to see the reaction happening within the flask. So let's go for the second part of the experiment into the dark room. Wow, that was an exciting reaction. That was truly beautiful, and I hope you enjoyed watching that reaction occur. Potassium hexacyanoferrate serves as a catalyst, or in this case, an oxidation agent in an alkaline solution. Luminol is oxidized in the presence of hydrogen peroxide. During this oxidation, luminol is converted into an excited 3-aminophthalate ion. When this excited molecule returns to its ground state, it releases energy in the form of a blue light. As discussed at the beginning of the video, luminol reaction is widely used in forensic science for detecting trace amounts of blood because hemoglobin catalyzes the reaction and produces a visible blue glow in the dark. It is also used in chemical and biochemical assays to detect reactive oxygen species or metal ions. This is an example of chemical reactions releasing light energy. And these types of reactions can be found in some living organisms. For example, fireflies and some sea creatures use such reactions to produce their own light. This phenomenon is known as bioluminescence. And the reaction involves luciferin, which is a light emitting molecule, and the enzyme luciferase, which catalyzes the reaction, and it often involves ATP or oxygen. These are often required for the reaction to occur. Well, I hope you enjoyed today's experiment, and please hit the subscribe button. It helps support my video. My channel keeps me making more and more videos. Also, please check out my Patreon page where I have exclusive videos of experiments that will not be shown on YouTube. I also publish all the recipes and background notes to all my experiments on Patreon and YouTube, and these can be found in my Patreon page exclusively for Patreon members. Please also feel free to leave a comment. Check out my link description because it contains all the information, all the resources that I use for developing and building and doing all my experiments. I list all my resources that you can look at should you want to do these experiments yourself at home. Also, feel free to email me your questions, your comments. Also, send me your photos and videos of you doing home lab experiments. I love to explore. I love to share, and I want to develop a home lab science hobby community. So please feel free to email me. So until next time, keep on experimenting. Goodbye, everybody.